Okay, so in this video, I'm going to cover how to use Eddy 3D to perform a simple airflow analysis in a kind of building volume. First thing I want to talk about just briefly is some notes on installation of Eddy. First of all, at the moment, Eddy is only compatible with Rhino 6. Find this information here on their website. If you just search for Eddy 3D, and then go to that website. So you go in here, this is where you download, put in your information, download your copy of the software. And the other thing you need to do is install a program called Blue CFD, which is actually the software that runs the airflow analysis. And for what we're going to do, we'll just need this software and an Eddy 3D. So if you just follow along with these instructions, you should be able to get it up and running. Okay, so once you have Eddy 3D installed, it should look something like this. It'll make its own tab and everything like that. And there's a lot of different tools in here, but one of the really nice things about Eddy is it comes with a bunch of templates that can be loaded through a component. This first tab here, if we click on that component and place it on the canvas, and then right-click on the box where it says right-click, these are all the example files or template files that it comes with. And we can pretty much just work from these, especially for what we're doing. So I'm going to use this one called Simple Wind Analysis. And you see there, it should pretty much load up the file. And if I zoom out here, you can see we have kind of a volume, we have kind of a ground plane and stuff like that. So I'm just going to unpreview everything to start with, and then I'll go through this bit by bit. The other thing that I just want to point out actually before I start on that, ultimately what we're going to produce is a kind of vector field of that represents the airflow around our object. Now, because I've done this before, and basically each time you open a new Eddy file, rather than making new directories and everything like that, because the way Eddy works is it runs in a separate software, it has to save files somewhere on your computer. You want to just click this button here that's all the way on the right where it says clean. And that will kind of erase all of the old files that are saved on your computer so that you can perform a new setup. So with that taken care of, I'll go over here on the left and start with these components here. The first one is kind of the setup of just our airflow. So the input there you see is basically the direction in degrees. So I can put in a number into that component if I zoom out here. And that'll change what direction my airflow is coming from. I'm going to preview this component in the next section called the domain box. And then if I zoom out enough, that component will give us an arrow that indicates what direction the airflow is coming from. So if I change this, for example, to 90 degrees, or I'll change it to 60. There you can see it changes what direction it's moving towards. I'm not going to change that to anything right now because I don't really need to. But just so you know, that's how you change the direction. I believe you can also, in here, you can change the like the 0 of the file. One thing, yeah, so like our Z0 is at 0 right now. Our Z level is at 0 right now. One thing to be mindful of is that in Eddy, it seems to matter when you have objects on or below the 0 plane in the Z-axis. And I'll explain what I mean by that later on, but just so you're aware, that is one issue. So then we need to set up basically two things. One of them is the stuff that we want to analyze. You can see here our file comes with some default kind of mesh objects that are sort of like a little cluster of buildings or something. And it also comes with a ground plane. which obviously affects airflow and air pressure and all that kind of stuff. For the moment, we're just going to ignore the ground plane, pretend that everything's flat, so I'll disconnect this. I'm also going to disable my, or unpreview my ground plane there, unpreview my domain box. So again, that's the basic geometry. I'm going to change this geometry. Again, because what we're going to do is look at the airflow kind of inside a building envelope. Obviously, we could look at the airflow, through a surface or like a skin, and we can also use it to analyze like large kind of urban conditions, more like along the lines of what we're doing here. But just to kind of give you a sense of how to input your own objects, I'm going to make my own kind of building here. So I'll make just a simple volume to start with, and let me unpreview this here so we can see better. Right. And then I'll make a couple of cutouts in this volume. So I'll just make another kind of box and intersect it with my original volume there. Copy of that one. I'll make this one a little smaller or something. Okay, so we're basically looking at a simple cross-sectional kind of airflow condition. I'm going to make this one a lot bigger, actually. Right, so let's imagine, and we already know what direction our wind is coming from, right, because we previewed this domain box. Let's imagine that's our inflow and that's our outflow. So I'm going to trim the volume with those two windows cut out. And then I'll offset this, give it a thickness. I'll type in offset surf. I guess it doesn't matter what direction I do it. Okay. And then I'm going to move it up in the z-axis so it's not below 0. Because again, it doesn't like to perform analyses below 0 in the z-axis. I'll move it vertically and move it up to 1. Sorry. Actually, I'm going to move it to 0. Okay, so it should be like sitting on the ground, basically. All right, so there's our simple volume. Obviously, it's modeled as a NURBS geometry, and we actually need it to be a mesh for Eddy to do its thing. So what I'll do is I'll translate it into a mesh in Grasshopper. That way that we can still edit the original geometry here easily, and our changes will just be automatically converted into a mesh in Grasshopper. So first I'll reference the geometry into my Grasshopper script. I made a brep component. I'll right click and go to set one brep. And I'm actually just going to hide it now and preview it in Grasshopper. And I'm going to double click and search for a component called mesh brep. Okay. And so if I plug that in, especially within a rectilinear geometry, you can see we have a relatively few faces. And I kind of want more faces than that. That'll help my analysis work better. So I'm going to double click on the canvas again and type in settings. There's a few different ones here, but I'm going to go for this one called settings custom. And if you look at the little text, subtext there, it says represents custom mesh settings. So this kind of gives us a bunch of options for how our mesh gets translated. You can see as soon as I plug that in, it makes more subdivisions in my mesh. The thing I found easiest, especially with rectilinear objects, is just to change the minimum and maximum, meaning the minimum and maximum length of an edge of the mesh. If I set the minimum edge, you can see that's pretty good at controlling how fine our mesh is subdivided. I'm going to leave it like there, but we don't need it to be too small. Okay, and now we have the mesh representation of our volume. And I basically need to replace everything that this template file mesh was originally plugged into. One thing I just want to mention really quick, this is actually a cluster, but so in this component, because we have several different boxes, they actually also join these meshes together. And the reason I point that out is because if you do have meshes that are multiple objects, even if they're not touching, you want to still join it. So Rhino will recognize a mesh object as a single thing when you join it using the mesh join component. And that's how the software wants to read that geometry. So if you have multiple objects and they're not touching, or they are touching, just go ahead and plug them all into mesh join before you plug them into any of the Eddy components. So I'll go ahead and replace the inputs on these two guys. Okay. And this one's throwing up an error for us. And there you have it. So if your simulation domain extends below Z0, you cannot use the boundary condition, et cetera, et cetera. So we need to move our object up just ever so slightly. Move it up by like 0.1. Okay, so there you go. That's how you set it. And so the domain box is basically just a kind of volume that represents it's like the wind tunnel. It's the amount of space that Eddy is going to analyze in terms of airflow around and through your object. So imagine we put a model of this thing in a wind tunnel. This represents the wind tunnel. Generally, you can leave this as default. The scale of things doesn't matter as much as the proportions of things does, obviously, with this kind of analysis. But you can actually change the dimensions of the wind tunnel if you would like, using the LWH inputs on the domain box. So that's what that is. And again, you can see the direction of our analysis is also represented in that component. Okay. So I'll preview that stuff. Now over here, there's another video. If you search for Eddy tutorials, kind of the most basic one, you'll find an explanation of what all these inputs do. Again, for the most part, you don't have to change anything. What I found is that I wouldn't even bother changing the file paths or anything like that. What I found is that if you do have issues, probably what you need to do is rerun the simulation, clean the file directory, or reopen the file. One of those three things. And that generally makes it work. One thing that I'll point out, at least in my installation of Eddy, for some reason this component that says 100, that's normally plugged into where this input where it says iterations wasn't plugged in. It's worth plugging that in, but the default value here is 1,000. And I can tell you that if you run your simulation with that default value, it'll take quite a lot longer than if you do it on 100. And 100 is plenty detailed enough. So just plug that in. The other thing that I've heard, and I don't know whether this is true or not, is that you are having issues getting your file to run. One thing you can try is to break out these two run mesh and run simulation inputs and do them in sequence rather than all at once. So now I'm gonna click this button, which will run kind of analysis of our mesh, and you'll see like the command prompt show up, and depending on the complexity of your meshes and stuff, it'll take a little while. In your computer, it'll take a little while, but that was not too bad. And then I'll click run simulation, and there we go. So that one's complete as well. And so down here at the bottom, we can also click this button, which will open up another piece of software that gives us kind of a readout of kind of the accuracy of the simulation. Again, you can learn more about that in additional videos if you'd like to. But so now our simulation is more or less complete. Basically, anytime I change something upstream of this component, I'm going to want to rerun that simulation. And then once I have this stuff established, moving over to the right. Yes, I did. Okay, just checking. So moving over to the right, there's a couple more things that we need to set up. One of them is what's called the mesh plane. And if I preview this on, you'll see this is basically a plane that represents where we're going to analyze the airflow. It's pretty big right now. And so I could make my own plane if I wanted to. That's sort of more scaled appropriately to my object. And maybe we want to look a little bit further downstream. Okay. And then I'll set that as my BREP to analyze. Now, this thing basically just turns our analysis surface into a mesh with a certain number of vertices. So if I preview this guy on, you can see there's a certain number of points that show up on that surface. And basically whatever I set this number to, the lower the number, the more points I'm going to have. And therefore the more vectors that'll be in my analysis. Once you have that set up, and again, remember you need your analysis mesh plugged in here. I'm going to go ahead and click this visualize probes button. That'll run the command prompt again. And then it should, so over here on the right, as long as I have this component turned on, it should now give us a series of vectors that are colored and dimensioned to kind of represent airflow and air pressure and things like that. And so there you can kind of get a sense of how the air would move as a result of these openings. I think we can actually make this even more points. So again, every time I change this, the number of points, it'll change my analysis. And I think if you get up around, so right now I have like 792 points, it says. If you get up around like 5,000, it'll start to complain that you're running too many points. But you can see you can get fairly detailed with it there. Yeah, the other thing you can do is over here on the right, if you click on this component where it says pair view, that'll also actually load up in the software. And you can kind of see here another version of the analysis of our mesh. Yeah, so that's what that does. Yeah, so basically anytime you change this, so the other thing you can do is you can create a, turn this back on so you can see better. You can create a horizontal plane to perform an analysis on. Now, just to give you an example here, if I use this as my plane, so I'll set one. So first of all, because I drew the plane just on the ground, basically, it's going to throw up an error that my object is not above 0, the z-axis. That up a little bit. And then basically, again, every time I change the inputs here or change this number, I'm going to have to rerun the simulation of this. But again, once I do that, I don't have to rerun this stuff up here. I just have to rerun that initial simulation. And so I can move this up to where one of my windows is. And get a sense of how air might move through there. And I'll go ahead and flip it, flip the direction. Oh yeah, So when you do that, you have to rerun the original analysis. Both of them. Yeah, it's still working. There we go. So that's basically that's Eddy. So yeah, and then so anytime you see something like this, basically what's happening is we still have the same number of points, and we still have the same kind of original simulation results, but we've moved our surface. So it's kind of randomly throwing vectors at the points. Basically, it's the data is jumbled up. So anytime you see something like that, that means you gotta again rerun the simulation, rerun the visualization part, and then it'll look nice and logical. Okay. And then I think the only thing I wanted to mention is this guy can also, we can change the thickness of those lines. But this guy can also, I think, be baked. Not sure. Not sure how you bake it actually. Right. Well, maybe you can't. Maybe you have to produce your simulation from screenshots and stuff like that. But I think the other way you could do it, if you wanted to, is you could color. You'd make a mesh that's subdivided kind of equally and color the mesh using the same procedure. And that would be something that you could bake, and it would retain the colors and everything like that. But anyway, so that's kind of the basics. Again, you could add a ground plane if you wanted to. But this will be kind of what we'll do to analyze this simple volume. All right, so I'm going to go ahead and end it there.